Hello my friends and welcome back to the You Can Do TV channel. In this video, we will explore the automatic production line of electric motor rotors and stators. Besides, we will also visit large engine repair and maintenance projects. Finally, there are useful machines that support the recycling process of electric motors and cables. The weight of this 60-ton generator delivered to Koffler for repair and maintenance required a 9-axle truck trailer because it was so heavy. The tail end of the trailer required a separate driver. Unloading the generator required the removal of the rotor from the stator while the generator was still on the truck. To accomplish this, 2 cranes were carefully coordinated by a team of experts. The rotor was moved to a temporary storage location. Located in San Leandro, California, Koffler Electrical specializes in the meticulous process of electric motor rewinding and rebuilding, offering a comprehensive range of services for motors of all types and sizes. At the heart of their expertise is the disassembly of a large, slow-speed vertical water pump motor, a testament to their proficiency in handling complex and substantial equipment. The facility takes pride in their rewinding capabilities, particularly evident in the servicing of a 5,000 kilowatts wound rotor. With a commitment to excellence, they ensure that their rewinding processes are second to none, delivering top-notch results in motor maintenance and restoration. The team at here excels in various winding techniques, showcasing their skill in random winding for multiple strand stator coils and layer winding for rotating field coils. Their expertise extends to the intricate processes involved in rewinding a DC armature, including insulation and the meticulous reassembly of layer-wound pole pieces with rectangular wire for a 5,000 kilowatts generator. The dedication to precision is evident in every step of the process, from making connections on main DC fields motor generator sets to the meticulous undertaking of commutator undercutting and the careful wedging of newly rewound stators. The insertion of coils in large wound stators and the installation of termination blocks for output coils in a 5,000 kilowatts generator further highlight the comprehensive nature of the facility's services. The culmination of these efforts is a completed stator, impeccably rewound and ready for assembly in a 5,000 kilowatts generator. The automatic new energy motor stator manufacturing process by Nide Group represents a cutting-edge production line tailored for the efficient assembly of electric car (EV) motor stators. Manipulator feeding. The process kicks off with the manual loading of the stator core onto the paper inserting machine via a cantilever. A QR code is printed on the stator terminal end arc side. Core shape inspection. This step ensures that the core meets the precise specifications required for optimal performance. Paper inserting and feeding. Insulating paper is inserted into the stator core. Insert insulating paper. Building upon the insulation process, additional insulating paper is inserted into the stator core. QR code scanning. Second scan. A second QR code scanning is performed, reinforcing the traceability of each stator through the manufacturing process. Winding and insertion material. The heart of the stator manufacturing process begins with winding and the insertion of materials into the stator core. First inserting. The initial insertion of winding material takes place, marking a critical phase in the formation of the stator. Precision and accuracy are paramount at this stage to ensure the seamless integration of components. Artificial alignment and first expansion, 4 stations, ensuring the alignment and expansion of the winding material are critical to the overall performance of the stator. This process occurs at 4 dedicated stations, employing a combination of artificial alignment and mechanical expansion techniques. Winding and secondary inserting. Building upon the foundation laid in the initial stages, the winding process continues, accompanied by the insertion of additional materials into the stator core. This step furthers the development of the stator's internal structure. Feeding of expander. An expander is introduced into the system, facilitating the expansion of the winding material. This controlled expansion is a pivotal step in achieving the desired shape and functionality of the stator. Second expansion. The winding material undergoes a second expansion, refining the shape and structure of the stator. This multi-stage expansion process contributes to the precision and reliability of the final product. Winding and 3 inserting. The winding process continues, accompanied by the insertion of additional materials into the stator core. This iterative approach ensures a comprehensive and well-integrated stator structure. Mechanical feeding. Mechanical feeding mechanisms come into play, streamlining the process of introducing materials into the system. This automation enhances efficiency and minimizes the margin of error in the manufacturing process. Pre-shaping. Pre-forming of terminal ends occurs at this stage, shaping the stator components in preparation for subsequent stages. This step is crucial in achieving uniformity and precision in the final product. Manual wiring. While much of the process is automated, certain stages, like manual wiring, require human intervention. Skilled operators manually conduct wiring, ensuring accuracy in the arrangement of components. Tooling installation. Tooling installation is a pivotal step that involves the setup of necessary tools for the manufacturing process. Star welding. Star welding is a specialized welding process applied to specific points in the winding material. This step contributes to the structural integrity of the stator, ensuring durability and longevity. The production line boasts a cycle time of less than or equal to 170 seconds per stator, emphasizing efficiency and rapid output. Tooling changing time for the entire line is within 2 hours, requiring the expertise of a workforce of around 10 individuals. The incorporation of Manufacturing Execution System (MES) ensures traceability throughout the production process, while electric boards monitor the entire line and its working stations. Fine shaping. Precision shaping of the stator components is carried out in this step. The intricate details of the stator are refined, contributing to the overall performance and efficiency of the electric motor. Double sides lacing. Lacing, a process of securing and bundling components, is performed on both sides of the stator. This double-sided lacing enhances the stability and integrity of the stator structure. Automatic final forming. The stator undergoes an automatic final forming process, where all components are brought together in a cohesive manner. This step marks the near completion of the manufacturing process. 22. Automatic slot end paper expanding. The stator slots undergo expansion, ensuring the proper accommodation of winding materials. Manual inspection of upender. A manual inspection of the upender is conducted to verify proper functionality. This hands-on check ensures that the equipment is performing as intended, minimizing the risk of defects. In a span of 8 weeks, Howden Maintenance Partners undertook the rewinding and balancing of a 15 MVA Ellen generator rotor, dating back to 1966. The stator, with a voltage of 10,500 volts and a power capacity of 15 MVA, underwent a comprehensive overhaul in the workshop, involving dry ice cleaning and the renewal of winding supports with epoxy material. After 5 decades of operation, the rotor's insulation had significantly degraded, necessitating a complete rewind for sustained reliability. A dedicated team of 3 electrical specialists, working in 2 shifts, diligently completed the rewinding within the stipulated timeframe. The intricate rotor, comprising 300 individual copper turns, underwent meticulous installation and insulation. Upon the installation of retaining rings, the rotor entered the realm of high-speed balancing. This process involved repetitive surge oscillograph (RSO) measurements to identify potential short circuits between turns. Balancing was executed at various speeds, reaching up to 3,600 RPM, with real-time correction indicators displayed on-screen. Multiple iterations were performed to eliminate imbalance, with the addition of balancing weights between runs to enhance equilibrium and eliminate vibrations. High-voltage electric motor rewinding is a process crucial for maintaining the functionality and longevity of motors. During routine revisions, motors undergo thorough cleaning and disassembly, with seals and bearings replaced for optimal performance. In cases of extensive wear or damage to windings, the go-to solution is rewinding. This process often boasts a shorter lead time compared to acquiring a replacement motor. Prior to commencing the rewinding of high-voltage motors, precise measurements and reverse engineering of coils are imperative. Aside from rewinding in workshops, services extend to the revision and replacement of laminated cores. Integration of cutting-edge materials by the engineering department enhances the motor's efficiency and lifespan. Post-rewinding, assembly follows, accompanied by detailed checks of mechanical and electrical components. Advanced testing methods such as ultrasonic and LCD are employed at this stage to ensure the motor meets stringent quality standards. High-voltage electric motor rewinding is an indispensable practice for industries relying on reliable motor operations. Generator stator rewind is a critical aspect of maintaining the efficiency and reliability of power generators, and MD&A Turbines stands out as a trusted provider with a proven track record. Stator bar aging poses a significant risk to generator performance, leading to cooling issues, conductivity problems, and potential failures. MD&A, with over 30 years of experience, offers comprehensive on-site generator stator rewinds, utilizing superior materials and expert technicians to ensure optimal results. For asset managers overseeing power generation facilities, minimizing costly outages is a top priority. Stator bar aging can jeopardize generator performance, making it crucial to choose a reliable partner for maintenance and rewinds. MD&A positions itself as a full-service OEM alternative, offering generator service, parts, and repairs. Their expert technicians specialize in various cooling methods, including water-cooled, hydrogen-cooled, and air-cooled generators. MD&A's approach involves a meticulous pre-outage planning process that assesses alternate approaches and establishes contingency plans, mitigating risks and ensuring a smooth execution. The company adheres to the strictest specifications, employing a wet tie method for connection ring and series blocking ties on conventional units. This method enhances durability, making the ties resistant to vibration and movement. In a specific case, the Lockheed Power Station hydro generator faced challenges such as noise and vibration issues in one of its generators. The owners, SSE, enlisted the expertise of Sulzer's Falkirk Service Center to address the problem. Sulzer, a reputable name in the industry, provided support and successfully completed the refurbishment project within 3 years. This underscores the importance of timely intervention and specialized knowledge in resolving generator issues to minimize downtime and associated costs. The installation of hydroelectric turbines, particularly the Wasquatim runner in Manitoba Hydro's Wasquatim generating station, is a complex process. The project has reached a crucial milestone with the successful lifting and placement of the third turbine runner, a massive component weighing nearly 150 tons. The project has transitioned from the initial stages involving heavy rebar, formwork, and concrete work to the more intricate phases of electrical, mechanical, turbine, and generator installation. This shift signifies a move towards the precise assembly of components that are essential for the efficient functioning of the hydroelectric system. One of the significant highlights of the installation process was the completion of a major lift in the powerhouse, involving the movement of the rotor into storage. This strategic step allowed for the continuation of the assembly in a systematic progression. Challenges encountered earlier in the project were met with innovative solutions devised by the contractor, ensuring adherence to the project schedule. Undoubtedly, large-scale projects like hydroelectric turbine installations present unique challenges, both major and minor. The turbine and generator components, with their fine tolerances for installation and assembly, require careful attention. The project team has addressed these challenges head-on, with dedicated individuals working diligently to overcome obstacles and ensure the project's smooth progress. As the installation progresses, anticipation builds for the alignment of all components and the moment when the turbines will be set in motion for the first time. The excitement among the team is palpable, and the progress made thus far is a testament to the collaborative efforts of many individuals who have worked tirelessly to find solutions and implement plans effectively. The satisfaction and reward lie in witnessing the plans and solutions developed during the project's planning stages being put into action. The successful installation of the Wasquateam runner reflects not only the technical expertise involved but also the commitment and hard work of the team, bringing the project closer to its completion while maintaining the intended schedule. This section will show how the Bromberg electric engine wrecker work. It is an effortlessly user-friendly and robust machine designed for enduring performance. This tool is your key to unlocking profit by recycling components from electric motors. Before diving into the mechanical recycling of the electric motor, it is advisable to unscrew and set aside outer pieces and attachments. This initial step unveils the genuine external housing of the electric motor. Bromberg's industrial electric motor recycler adopts a meticulous three-stage process to extract valuable materials. In the first stage, the operator triggers the separation and removal of the outer casing, exposing the internal components of the electric motor. The splitting apparatus exerts intense pressure, cutting the cast iron or aluminum housing on opposing sides. This process peels away the housing, revealing the inner workings, and subsequently, the anchor rotor is detached. The second stage involves cleaving the stator or transformer block into two equal parts. This action reveals copper coils, now primed for separation from the remaining components. The third and final stage employs a sophisticated hydraulic system to pull the copper wiring away from the surrounding metal. This process literally removes the housing, leaving the copper wiring completely exposed and detached. The result is a volume of valuable copper wiring cleanly separated from a pile of scrap metal and plastic, materials that can also be recycled. Experience a groundbreaking shift in the extraction of valuable copper and aluminum from electric motors with the innovative system. This revolutionary technology transforms what was once a lengthy, labor-intensive process into a series of simple, repeatable steps. The in-house electric motor recycling system ensures maximum returns from copper and aluminum scrap, offering an efficient and effective solution for the growing demand in recycling electric vehicle components. As the sales of electric vehicles surge and older equipment is phased out, the need for streamlined recycling processes becomes paramount. Stay ahead of this demand by investing in the electric motor recycling machine, designed to process over 20 motors per hour with just a single skilled operator. This unique system not only enhances productivity but also prioritizes safety through its semi-automated and ergonomically designed features, mitigating worker fatigue and repetitive stress. The full automatic electric AC motor assembly line for induction motors stands as a sophisticated solution for the efficient assembly of various induction motors used in appliances like washing machines and fans. This comprehensive assembly line is divided into two main segments: the stator production line and the rotor production line. The focus here will be on the stator production line. The assembly process begins with the stator insulation paper inserting process. An automatic stator slot insulation paper cutting and forming machine is employed for this stage. The machine precisely cuts and forms insulation paper to fit the stator slots, ensuring optimal insulation between the windings. Moving on to the stator coil winding process, an automatic stator winding machine takes center stage. This machine intricately winds wires around the stator core, creating the essential coils that are fundamental to the motor's operation. The precision and efficiency of this process are crucial in determining the motor's performance characteristics. In general, the stator is constructed from high-grade alloy steel laminations designed to reduce eddy current losses. It comprises three main components: the outer frame, the stator core, and the stator winding. The rotor, also constructed from laminations, is mounted directly on the shaft and comes in various types. The outer frame serves as the motor's outer body, supporting the stator core and protecting the internal components. The subsequent stator coil inserting process involves the utilization of an automatic stator coil winding insertion machine. This machine is responsible for inserting the pre-wound stator coils into their designated slots within the stator core. Proper alignment and placement of these coils are imperative for the motor to function optimally. The stator coil forming and shaping process follows suit, employing an automatic stator winding pre-shaping machine. This machine ensures that the pre-inserted coils are shaped and formed to conform precisely to the stator core. This shaping process is vital for maintaining the structural integrity of the stator assembly. A significant phase in the assembly line is the stator coil lacing process, which takes place at 4 dedicated stations. An automatic stator coil lacing machine secures the coils in place through a lacing process. This step enhances the stability and durability of the stator assembly, ensuring its resilience in various operating conditions. The final step in the stator production line is the stator coil final forming process. This phase utilizes an automatic stator winding final forming machine to give the stator coils their ultimate shape and position. The precision and accuracy of this process contribute to the overall efficiency and reliability of the motor assembly. The electric induction motor, characterized by its cost-effectiveness, robustness, economy, and reliability, is particularly favored for industrial drives. The first integral component of this assembly line is the Tubular Motor Stator insulation paper inserting machine. This automated system precisely inserts insulation paper into the stator slot from the bottom. Following this, the Tubular Motor Stator winding and coil inserting machine takes center stage. Equipped with 3 coil winding stations and 1 coil insertion station, this machine is versatile, catering to a range of applications including lifting machinery, tubular motors, electric drainage motors, fans, induction motors, air conditioner motors, washing machine motors, compressors, generators, and pump motors. The next step in the assembly process involves the Tubular Motor Stator coil forming machine. Driven by a hydraulic system and programmed with PLC, this machine ensures precision in coil winding and forming. Individual guard teeth in each slot, along with meticulous attention to field wire and jump wire placement, guarantee the reliability of electrical leakage distance, crucial for the safety and efficiency of the motor. The assembly line is completed with the Tubular Motor Stator coil lacing machine, featuring 4 working stations. This machine is versatile, accommodating a range of motor types, including tubular motors, air conditioner motors, pump motors, compression motors, fans, washing machine motors, and generators. The lacing machine plays a vital role in binding the stator coils securely, contributing to the overall robustness of the electric motor. The tubular motor, a key component assembled through this production line, combines the functionalities of a motor and gearbox. The motor, typically a DC motor, stepper motor, or brushless motor, provides high-speed, low-torque output, while the gearbox, connected to the motor, facilitates the desired transmission effect by adjusting speed and torque. This system is customizable, allowing for variations in gearbox ratio, torque, and rotation speed according to specific requirements, showcasing Nide Group's commitment to flexibility and precision in electric motor manufacturing. The rotor winding machine by Taze Visiton is a sophisticated tool designed for efficiently winding generators or electric motors with 4 to 20 poles. Specifically crafted for salient pole machines, it accommodates rotor stacks with a length ranging from 500 to 1,800 millimeters and an inner stack diameter of 200 to 900 millimeters. The outer stack diameter can vary between 600 and 1,600 millimeters, supporting rotors weighing up to 16 tons. The pole winding, reaching a maximum length of 3,000 millimeters and a weight of 4 tons, utilizes copper profile wires. The machine has a tension strength of 0.1 to 10 kilonewtons. The hot crimping machine from Taze is a cutting-edge tool tailored for crimping cable terminals in cable lugs of stators and jumpers. Equipped with top-notch components, including Amada Miyachi welding equipment, an AC power unit M4P, a welding transformer of 60.0 kA, and a Siemens control system, it ensures precision and reliability. With a crimping element range from 10 square millimeters to 100 m squared, the machine incorporates advanced features like detection and identification of correct pieces, weld deformation control, and the option to seamlessly integrate into a production line. The crimping cycle starts effortlessly with a control pedal, making it a versatile and efficient solution for cable termination. The Vonner MRT electric motor recycling machine is a sophisticated piece of equipment designed for the efficient extraction of copper from motor stators. Its operational capabilities make it an ideal choice for a variety of motors, including those found in household appliances, washing machines, and industrial motor stators. The process begins by placing the motor stator into the machine, which can handle stators with an outer diameter ranging from 8 to 30 centimeters. The machine consists of several key components, including a hydraulic pump, hydraulic control system, tangential cylinder, pole cylinder, and electronic control system. These components work in harmony to ensure a seamless and efficient recycling process. The first step involves cutting the stator or motor in half, setting the stage for the subsequent copper extraction process. The hydraulic system employed in the machine facilitates stable disassembly, significantly enhancing efficiency and reducing labor intensity. The cutting blade, constructed from high wear-resistant hard alloy, ensures ease of operation, reliability, and swift cutting without producing adhesion or burrs. To further streamline the operation, the machine is equipped with an automatic thread gripping device. This feature substantially reduces labor intensity during the cutting and recycling process. The cutting blade and gripper are adjustable, allowing for the optimal placement of the stator coil. The Mr. T electric motor recycling machine has two main parts: the cutting part on the right side, which divides motor stators into two parts, and the copper pulling part on the left side. The copper pulling mechanism efficiently dismantles scrap motor stators within a diameter range of 8 to 30 centimeters. Vonner Machinery has designed and manufactured the Mr. T with a focus on quality and efficiency. The machine ensures 100% separated copper, boasts low energy consumption, utilizes high-quality accessories, and features a durable design. Additionally, it incorporates a dust removal system and a reliable hydraulic system, contributing to its overall efficiency. V200M wire stripping machine is used for scrap armored cable wire cutting and stripping. It is an efficient cable wire recycling equipment. This machine can separate the cable core from the cable jacket, the blade cuts the cable jacket, and the roller separates the core from the jacket by squeezing. The machine has a total of one hole, including one round electric cable wire hole. It is stable, easy to use, and very practical, so it is the most common wire stripper. Above all, wires ranging from 60 to 200 millimeters armored wire will easily strip on this machine. Pacer wire begins as finely stranded, tinned copper conductor. Feeders guide our conductor off the reel and into the crosshead. PVC compound is used to form wires insulation. First, resin pellets are added to the hopper. PVC compound travels up to the hopper. There, it is mixed in a precise ratio with the colored resin. Mixture passes into the extrusion machine. Here, it is melted to a smooth, flowing consistency. The compound flows into crosshead and over the conductor. Crosshead tip ensures compound encases the copper evenly. Newly insulated wire enters a water trough to begin cooling. Print wheel applies legend with UL and CSA compliance info. The paint dries quickly on the still hot wire. Next, the wire passes through a laser micrometer. Micrometer samples wire diameter multiple times per second. This ensures the wire diameter is uniform. Wire continues to cool in another water bath. Next, cooled wire enters the spark tester. Thousands of volts test the wire as it passes beaded chains, thus ensuring the electrical integrity of the wire. Completed wire is now gathered onto large master reels. Wire can then be spooled to customer specification or used in the production of Pacer's range of boat cable. In the next section, we will visit Osran's electric motor factory in China. China Osran Electric Motor Company is one of the largest electric motors factory in China. Finished products. Motor simulation test. The technician is monitoring test. Blower motors are testing. Motor stator winding automatically is bound. Test motor parameters such as power, speed, and current. Insert insulation gummed paper to the stator. Robot is welding electrical terminals. The technicians are assembling and testing on production line. The engineer is drawing attentively. Implement production. Cutting, stamping large steel plate. The CNC lathe is processing precisely. Ultra-large steel plates are processing. Automatic assemble the motor's stator and bearing. The motor stator is winding automatically. Motor's accessories is processing. Laser processing. The robots are processing motor's accessories. The technician continuous check and test the motors on the production line. The technician use comprehensive testing console to improve efficiency. Motor stator's steel core sheet stamping workshop. Motor stator stamping workshop. Workers are stamping stator's steel core sheet. Manipulator production. Stack of motor housing. Transport the shell to assemble. Motor rotors are waiting for assemble. The worker is sling motor to assemble. The motors are assembling. Motor stator's warehouse. Motor stators are waiting for dipping insulating varnish, VPI processing. Motor stators are dipping insulating varnish. Motor post-processing. The finished motor store. Household motor stators steel core are stamping. Household motors winding is assembling. The motor stator's winding automatically is bound. The stator winding is shaped to beautiful. Home heaters are assembled. A large stator is a critical component in the construction of electric motors and generators, commonly used in various industrial applications. The stator is the stationary part of the machine, surrounding the rotor, and is responsible for generating a magnetic field that interacts with the rotor to produce mechanical motion. When dealing with large stators, the winding process becomes a complex and precise operation, demanding careful attention to detail and adherence to specific procedures. The winding process for large stators involves carefully placing conductive wire around the stator's core in a specific pattern to create the necessary electromagnetic fields. Here are some key considerations and notes when performing the large stator winding process. Stator design and materials. Before beginning the winding process, engineers must ensure that the stator design is well suited for the intended application. The materials used for the stator core should be chosen to withstand the mechanical and thermal stresses it will encounter during operation. Wire selection. The selection of the wire is crucial as it determines the electrical and thermal properties of the winding. Engineers must consider factors such as conductivity, heat resistance, and mechanical strength. For large stators, the wire diameter and insulation properties play a significant role in the overall performance and reliability of the motor or generator. Winding pattern. The winding pattern is determined by the motor's specifications and requirements. Common winding patterns include concentric windings and lap windings. The pattern must be precise to ensure the electromagnetic fields are generated correctly and the motor operates efficiently. Tension control. Maintaining proper tension during the winding process is crucial to ensure uniform winding layers and prevent damage to the wire. Automatic tension control systems are often employed to achieve consistent tension throughout the winding process. Insulation. Adequate insulation between winding layers and phases is essential to prevent short circuits and ensure the longevity of the stator. Engineers must carefully apply insulation materials and ensure proper curing to guarantee the stator's electrical integrity. Slot insulation. The stator core is typically divided into slots, and insulation is applied to these slots to prevent electrical contact between the winding and the core. Proper slot insulation is crucial for preventing electrical faults and ensuring the stator's reliability. Quality control and testing. Throughout the winding process, quality control measures should be implemented to detect any defects or irregularities in the winding. Comprehensive testing, including insulation resistance tests, high pot tests, and continuity checks, should be conducted to ensure the stator meets performance standards. End turn lacing. The end turns of the winding are often secured with lacing or banding to prevent movement and maintain the integrity of the winding. Proper lacing techniques should be employed to ensure the end turns remain securely in place. The cable box is a revolutionary innovation in the field of cable recycling, offering a ready-made solution that integrates seamlessly with a complete cable recycling line. This compact, mobile, efficient, and economical system is designed to condense all the equipment of a standard MTB recycling line into combined containers, comprising two 40-foot containers, one 20-foot container, and one 10-foot container. The result is a plug-and-run concept that is fully integrated and ready for use without any assembly operations required. The cable box is designed to handle a diverse range of input materials encompassing various types of cables and metals. The system processes these raw materials into refined output, including valuable metals like copper and aluminum, as well as plastic materials. Here's a more detailed breakdown of the input and output materials, as well as the specific modules within the cable box that contribute to the recycling process. The cable box is equipped to handle a variety of cables, including standard cables and more challenging ones made of copper or aluminum. ACSR, aluminium conductor steel reinforced cables, which consist of aluminum wires wrapped around a steel core, are processed in the cable box. Radiators containing metal components are part of the input materials processed by the cable box. One of the key features of the cable box is its ability to retain all the essential equipment found in a standard MTB recycling line while ensuring easy mobility and versatility. The compact design allows for easy transportation, and the system can be set up quickly by connecting the containers. This user-friendly approach makes the cable box an efficient and convenient choice for cable recycling operations. The cable box includes various modules dedicated to different stages of the recycling process, ensuring a comprehensive and efficient operation. The shred box, for example, features a shredding module with a robust and powerful compact shredder capable of processing a wide range of cables, including difficult ones made of copper or aluminum. Additionally, a granulation module with two granulators reduces the material to the optimum sorting size. To maintain a quick process and easy installation, MTB has equipped the system with an air filtration unit in a separate container known as the air box. Despite its compact size, the air box contains a powerful dust collection system essential for the optimal separation of products. The sort box is dedicated to sorting and consists of density air tables, screens, and magnetic pulleys similar to those found in larger-scale recycling lines. This module allows for the recovery of sorted materials at the end of the process, including ferrous scrap, big copper nuggets, copper fine fractions, caps, aluminum, brass, tin, and plastic. The 10-foot container is specifically dedicated to dust collection and sealing the system. It is divided into two parts, housing dust collection drums and an isolated premise that can be used for storing wear parts or as a warm shelter. This container ensures a clean and controlled environment for the recycling process. The cable box emphasizes its commitment to being compact and green, offering a turnkey cable recycling line within containers. It is designed with a soundproof system to minimize noise pollution and reduce dust emissions drastically. The system also features an intuitive and integrated monitoring system for efficient operation. With a focus on minimum size and maximum efficiency, the cable box can be fed either by crane or belt conveyor, utilizing MTB's heavy-duty machines known for their power and reliability in both granulation and sorting. The system is designed to reach a capacity of up to 3 metric tons per hour, with output products including ferrous, non-ferrous, and plastic materials. An automatic bin feeder with visual control and a level sensor adds to the efficiency of the recycling process. The plug-and-recycle feature of the cable box makes it user-friendly, requiring only one assembly operation for the external 15,000 CFM dust extraction unit. Operators can undergo training before the installation of the box, ensuring smooth and effective recycling operations.